Ja, willkommen zurück.
Welcome back after the short break. Now, thanks for your understanding. I think it was a good idea to have a break, not just for the next presenters. Now, let's continue with part 2, which won't be any less interesting. Mind you, I dare say it might even be more exciting than part 1, because now we have heard a lot about the AI industrial cloud. But the question is, isn't that, cloud computing is kind of abstract, isn't it? So what do you do with it in the first place? And one important aspect of the industrial AI cloud is a Deutsche Telekom product. And the responsible board member from T-Systems will tell you all about it, Ferri Abolhassan. And that's the T-Cloud. Over to you. All right. Guys. Now, let's drive the energy level up a little bit. Few people have already left, but we're still keen to learn something, right? And I'd like to ask the audience here to help me out. I don't know who's from Telecom and who's from the media. Let's just pretend that we all care, about what Mrs. Baer was talking about. She said that over the past 5 to 6 months, a lot of things have happened. Actually, it's only been 5 months because it happened around Whitsun. At Whitsun, we had a startup weekend, if you will. And people often say, Telecom, that's a big company. It's hard to get things off the ground there. I can tell you that Whitsun weekend was a long weekend, 4 days. And in these 4 days, we made a lot of phone calls with SAP, NVIDIA, and with you, Jacomo, with a lot of the people gathered here, because we wanted to answer the following question, after everybody said we're going to have the big gigabit factories, etc. And when it comes to the big gigafactory, everybody, including the media, would always ask the same question, right? I mean, maybe you're still asking the same question, and today we have an answer because there's no excuse. And that question is, does anybody need that in the first place? Is it really worth investing so much money in hardware, software, data centers, etc.? And we said, all right, guys. So, you see, on the one hand, we understand that Germany and Europe are debating about sovereignty. And yes, this is an important debate, as we've heard. And we've also understood that we want to say we need courage, we need entrepreneurial spirit. And with that, we are supporting Germany and, if applicable, also Europe. But how specifically? Especially now. Because the good thing is, if somebody makes the first step, then everybody says, will that work out? Isn't that a risk? Do we have customers for that? And that's why it was clear from the outset that we had to make sure that this very first step was successful and helped us bring other people on board who actually use that. So I am actually pleased that I am now giving the first presentation after the quick break to tell you what this is actually all about, what we are using it for. It is a real startup, that we've set up over the past 5 months here. It comes with the, from the idea to contracts right through to the actual usage. And it is something else. Because if, let's say, I'm from an SME, from a small and medium-sized enterprise, then I would probably ask, what can I do with it? And, we have people from Agile Robots here, or we have Jacomo from PhysicsX and Siemens and other companies. I mean, you might then be saying, all right, again, that's the big companies, isn't it? Well, let me say, we also have some very fast companies on board and smaller companies as well. But now let's look at things from the point of view of the end consumer. When you look at pharmaceutics or chemicals, defense, quantum systems is very active in this field. Let's just pretend there is an industrial account, someone who's producing ACs, air conditioning systems. And these ACs may be working sometimes, but sometimes not. And so we need quality checks. And for that, you need something like predictive maintenance. But that's nothing new, is it? However, can you do it in the most modern fashion? And then maybe, that person hears about how people use that in the US. If the AC is making a certain noise, then that already indicates that something is wrong. And then AI comes in to fix it. So that, would be a challenge, for a company that can't afford hundreds of people working on IT, developing the right language models for that. So you need to have someone who uses this process expertise and says, we're going to use it now, and anything else we'll be doing with you step by step. And the customer will then be saying, what does that mean, step by step? Well, at the end of the day, that's the Deutschland stack, the Germany stack. So this is the data that you use as a basis for an AC, that a company may have engineered. And sometimes it works, sometimes it doesn't. And then you train this system through the years. You put it into the factory. And for that, you need a base plate. And that base plate is the data center. And that data center is located in Germany. Of course, you also need connectivity. It needs to be connected in such a way that the customer can use it and network with others. It needs to be secure, and you need to orchestrate things. And this orchestration, at the end of the day, is safeguarded by the cloud. And I would like to put the center stage for a moment. And on top of it all, you need this one thing, which is kind of a Steckerleiste, as we call it, that you can use to connect the various applications. And so SAP is providing that with a BTP platform. And we can use it, like I said, as a connector strip, if you will, a power strip, a Steckerleiste, as we say in German, to connect all those applications. Then you have an open and secure and sovereign stack. And it is open because it can not only be used by the big corporations, also by smaller ones, and it uses different models. And we have three target models, B2B to C. That's what. And we will hear more about that from Perplexity later on. Aravind will talk about it. This is something else that we are doing with this factory as a role model for others. And we are also working in the field of defense. And yes, this is something we need in this country. So, Sven, I'm glad that you're here today to talk about that. That said, you saw the chart that Tim showed you. And if we put all that into the Germany stack, then the question is, how can SMEs actually start working with all these great partners and use all these applications? So this is kind of the menu here. And I just picked predictive maintenance. It may be boring, but it's, something tangible. It is something that German SME customers need, but they want it in the most modern, in the best, and in the safest way. And for that, you also need some sort of hub that can be used to orchestrate it. So we've heard today that sometime in January, this thing will be up and running in Munich. And it'll come with things like this one here on the stage. So how can I get into it? Well, that's what where our T-Cloud comes into play. And it doesn't come with any Chinese components, mind you, so don't even worry about that. It's sovereign and secure. So now this SME person could say, in order to manage my ACs and the production better, I want to lease GPU power as part of a subscription, maybe month-based or per year, sandbox packages, and always cheaper than with a hyperscaler. You might want to jot this down. Or you could say, I already want trained models like the ones from you, Giacomo. Or you can say, I want the whole service. And in order to use these three models, It's cost-effective. It's open and sovereign, but you need a gateway, and that gateway is the T-Cloud. And the T-Cloud comes with a landing page. We're currently drafting it, and it will be up and running in the first quarter, and it'll come with standard VPN channels. So I'm trying to explain to you very specifically what this thing actually is, where an SME person, maybe someone with a company with 14 employees, where that person would be saying, this is what I want to do. And for that, you need a landing page, and that's what we're building right now. And then later on, my colleagues will be showing you what they're doing with it exactly. I am just kind of doing the warm-up here. So the Germany stack is here. There's no excuse. And I'm just the supporting act here, you see. And yeah, so let me say a few words about the T-Cloud here. You know, everything we do here is telecom. It's not just T-Systems. And we show one face to the customer. And telecom has been a cloud pioneer in Germany. And through the years, we've worked on a multi-cloud stack. And actually, it's a stupid question to say, are you doing hyperscalers or something else? That's a stupid question because we do whatever the customer needs. And in the way the customer needs it, public or private, and how much sovereignty do you want, and what do you already have? I think an exclusive strategy would be wrong. It needs to be an inclusive strategy. I'm working with customers such as Heineken or Shell. With this sort of customer, it won't be possible to say, I only want this or that. So we're saying, okay, let's form the best hub from both worlds. This is what a competence that telecom and T-Systems have developed through the years. And we've got the power. We have 7,000 customers worldwide, you know, the who is who of the big customers. And, you know, our TDG colleagues, for instance, are helping us to bring in customers from Germany and SMEs. So we are a cloud pioneer, have been for many years. And the best example for that is not just, you know, the terabytes and teraflops and the number of data centers we're running, but the best proof of us being a cloud pioneer is our customers. And that these customers are the who and who of, you know, the large customers out there. And last year, we celebrated our 20th cloud anniversary, T-Cloud at home. And this T-Cloud is now included as one stack in the Germany stack. And this Germany stack will go live in January, both for private industry and for the public sector and for sectors such as defense. And just like in the industrial area, private and public, I am proud to say we are making a lot of progress. And now I think I am handing you over to Zhaopeng from Agile Robots, but that Philip will tell you all about it.
Thank you very much. And yes, indeed. As I said before, there are many exciting topics that are awaiting you. And you see the robot, he's applauding already, giving us a hand. So I'm looking forward to the next presentation because here we will learn about how robots are going to help us. I mean, not only how they are being programmed, but how can they help us in cabling, basically, and wiring our data center.
Well, it has been working here for over the 4 hours, so good to see. Hello. Hello, everyone. My name is Zhaopeng Chen, and founder and CEO of Agile Robots. Thank you very much for inviting me for such a very important event. I was working in German Space Center for more than 10 years before I found Agile Robots, and I love robots. That's one of the reasons why I founded Agile Robots, and to realize physical AI. This is actually the ultimate goal from the first day of foundation of Agile Robots. If you look at the video here right now, is that after 7 years of operation, we are able to provide a wide range of different products from AI-driven factories to multi-sensory robots, and from manipulation capabilities to mobility, and from productivity actually to healthcare. So we're only 7 years old, but we're growing very fastly. Today we have over 2,500 employees over the world, and more than 2,000 of them are engineers. We actually founded the company in Munich, that's our headquarters, and then we have over 10,000 square meters lab and office spaces in Munich. We have 3 factories all over Germany. We provide more than 20,000 robot capacity for the global markets. The unique part of us is that we do everything in-house, all the key technologies, from actuators to gear systems, from sensory systems to joints to robotic systems, from robotic OS to the robotic foundation model. And these kind of like AI-driven solutions that's what we provide for the whole industry. With our AI-driven robotic solutions, we serve clients from different industries, from manufacturing to consumer electronics to automotive and to logistics. So in order to reach such a generative and general purpose robots and reach general purpose physical AI, we spend most of our efforts on 3 pillars: robotic body, robotic brain, and data. And we're making large scale of general purpose robots, the biggest robotic foundation model, and collecting large scale data. So our data matrix consists of mainly 3 layers: simulation data, robot data, and human data. This is one of the illustration out of a video of how the composites of data layers. So we're training our robots in simulation and transfer them directly with all the skills into physical robots. We're collecting large scale and physical data in our robot data farm. And most importantly, we collect data continuously from hundreds of thousands of our robotics applications. That means we basically close the loop of the AI-driven flywheel, and now it's only a matter of time. Our foundation model, different data sources and also applications for different industry coming together to industrial AI cloud. Our foundation model requires continuous training and also improvement of neural network architectures. So that's the reason why those models are actually integrated into our different platforms, which requires the data infrastructure and AI infrastructure. This AI industrial cloud gives us the computing power which we need, and to generate the next generation of a foundation model and next generation of general purpose robots. So that's all from my side today, and thank you for the attention.
So thank you very much, and you guys are very disciplined. Thank you so much. So we have enough time because those are very interesting and important topics. We take the time that we need, but we have others waiting. So not being an expert, I would say we are here more on the hardware side, whilst if I have gotten it right, Wandelbots is more a bit on the software side. Both very interesting showcases, and therefore I'm really happy that we have Christian Piechnick here with us to give us his presentation. Christian, thank you.
So, hi everyone, now from building robots and to how to run and operate robots. in Germany, and we often forget this, we are currently in a situation of, despite the deindustrialization and economic downturn, that we have a labor shortage problem of skilled labor, and this is not getting better. So at least in the next 18 years, that can be predicted very well. That's going to be a challenge, and it's not the only one. So escalating operational cost and rising ESG pressure is making Germany more and more unattractive as a place to produce. On the other hand, due to the geopolitical situation we're in, reshoring and nearshoring are the only answers we have. And in this balance, the question is, what do we do? What do we do in order to keep Germany as a place for producing goods relevant? And robots and automation is one of the few things we have available to kind of keep up and even grow the productivity, even though we have fewer people available. The problem with today's types of automation and the way how we do it, typically it's super expensive, it's really, really complex, and it makes your production extremely inflexible. And that's why the major number of robots you see in German manufacturing is in automotive, electronics, and only where you have so-called low-mix, high-volume production. Sorry to do that right now, but I have to kind of correct something Jensen earlier said. So the number of robots being deployed in modern factories is much lower than we expect. So in Germany, and that's one of the highest automated countries on the planet, we see approximately 5% of automation compared to manual labor. And even in automotive, the entire final assembly is mainly manual. So there is a giant potential to go forward. The problem is that, so maybe not with agile robots, but with the vast majority on robots you see on the market, you have those AT type of technology available. And we think that the future of production, future of factories is software-driven and based on AI. So basically what we bring to the party is the world's first fully robot-agnostic operating system. And that's not only standardizing use, making robots accessible, making it as easy to use as a smartphone. It's also for training robots, the entire workflow from having the first idea on automation, planning factories, planning new cells, to building them up, to running them on the shop floor. Digital twin, and when we speak about AI, is one of the key technologies here. So in order to apply AI to a production environment, the AI needs data to access, and AI needs an environment to learn in. Unfortunately, in the last 20 years, when we were speaking about digital twin, this was more like this. So it was more like digital old uncle, so the guys on a wedding you don't want to speak with because they sit in the corner being drunk. What we have now available is a set of technologies which are game-changing. So we can simulate physical production environments to an extent, to a degree of reality that's outstanding, and that's the foundation to apply AI at scale in manufacturing. So I've brought small examples. So we are working with large enterprises in manufacturing to softwareize their shop floors to small and medium-sized enterprises. And I would like to show you one example.
Industrie im Allgemeinen, als auch für uns als Volkswagen ist
So, as Volkswagen, for example, transformation is very important, and electric mobility is something that we are looking at, and we want to be flexible, react flexible, changing market conditions, and that is really a major challenge for us. I'm Tina, and for over 20 years I've been working at Volkswagen's different types of responsibilities in IT, manufacturing. Right now I'm responsible for innumerability and innovations. the CTO, basically, of the Dresden manufactory. And in addition, I'm representing Volkswagen as member of the board in the Industrial Digital Twins Association. We are driving the application of a standardized digital twinning for industry because that is an important technological module, and therefore, as Volkswagen, we are a member of this organization. So digitalization plays a major role for us. Also in terms of using the technologies of digitization in order to also make it usable in a metaverse. And Nova potential, I believe it's very good to have an open technology platform that makes it possible to also be integrated into our complex into our complex infrastructure. Wandelbot has that Nova idea, and it's a great module in order to make it possible for us to actually enter the possibilities and opportunities of the virtual world. So what you have seen here, this is just one example of how we actually use NVIDIA Omniverse together with Nova. We're in a virtual world. I'm planning for plants, and the time to bring robots on the ground basically can be sped up by 30 to 40%. And of course, you can scale this up. So I'm also going to give you another short example, and then I'm done. So this is one of the oldest and leading engineering service providers in Germany. I think it was founded in the 60s. Our cars were actually developed and plants, also designing products for German industry. EDAG is a company that is now starting to actually integrating Omniverse and its processes, planning industries per se. And on the basis of a digital twin, I can analyze, the problems, I can simulate them and produce solutions. These generated solutions I can plow back into the processes. So actually I'm saving a lot of time, and I can see where is the problem in my production process, and I'm not using, thousands of engineering hours, making calls, etc. No, it's a lot faster, and the downtime is down, by 90%. So I believe that it'll take 10 to 15 more years before in Germany we are going to have production processes of this sort. However, 15 years from now, when looking back on where we were now, I believe that today is going to be seen as a milestone, because this is basically where Europeans come to the fore. They don't want to be dependent on Chinese or other countries in this regard. And now it's an infrastructure project that we are putting off the ground, and we are very, very proud indeed to be able to take it off.
Computer. Roboter und Engineering.
Robots and engineering was the topic now.
Engineering, what we are going to hear from our partner, from our longtime friend, I would say, PhysicsX is a company that we are already long working together with. Speaking about engineering, in the past at work, I went to my researcher and developed a department, and I said, guys, go and develop something. But this is long ago. The way how it should work today, Jacomo Corbo will present to us. And Giacomo, I must say, for everyone who wants to know what you're doing, you just have to access your website, those wings, and what we heard about the wind channel and all those optimization. It's already from the picture, and with me not having that much knowledge about what you are doing, very impressive. So you're using the T-Cloud, and you are going to use the industrial cloud as well. We are really happy to have you here. This is your stage. Thank you.
Well, it's a real delight to be here. My name is Jacomo Corbo. I'm the co-founder and CEO of PhysicsX. It's a big day for me and for PhysicsX. I'm European. My two co-founders, one of which is here, Nico Haig, is German, and Robin Tului. And so, we're really delighted to be able to announce that we're available on the industrial AI cloud. What PhysicsX is doing is building a new engineering simulation software stack, reconceived from the ground up for AI, and we're using that to reimagine what engineering and manufacturing and production look like in some of the most important industries, in some of the most complex applications. Around hydro turbine design, we're using it to rip out about 2/3 of the engineering hours required to be able to customize a hydro turbine for a given customer installation, some hydro turbine that's going to be built somewhere. Like, these are processes that take more than 100,000 hours, and then we're able to reduce that down to about 40,000 hours. Reduce the cycle time from some 13 months, more than a year, down to less than half a year. And critically, reduce the dependency on certain specialist engineering roles, right? We've all heard about the bottleneck of scarce engineering resources, of a shrinking labor source, but nowhere is that hitting industry more than in the worlds of engineering and manufacturing. Around automotive EVs, one of the very important parts to extending the range of EVs is a housing for the battery that keeps it operating within its optimal operating window. And over the course of last year, we've been working with an automotive OEM in order to be able to take its best performing cooling jacket and to increase its performance by some 35%. And working around chemical reactors, these involve incredibly complex simulations where we've been able to take some 2-week-long simulations. That's a single simulation that takes some 2 weeks down to running it in some 3 hours, which ultimately allows us to bring these chemical reactors into production a whole lot more quickly, from something that takes about 2 years down to something that takes about 6 months. And the way in which we're doing that is by changing what simulation looks like. So much of engineering runs through understanding performance, and performance runs through being able to simulate physics and chemistry. Now, a lot of that is done numerically. And so if I'm designing an aircraft body, or designing the wing, I need to understand how air is going to flow over that wing around the engine. And just the 7 seconds of transient simulation that you just saw requires some 4 days of computation time. It's incredibly computationally intensive. It takes a lot of time. And we're able to move that to inference to 6 seconds. Just think of that. 4 days of compute down to something that takes 6 seconds. Across different physics that we can handle, we can do that with an acceleration of anywhere between 10,000 to close to 1 million times. And we're able to do that because there's a revolution afoot around AI for physics. This isn't just touching airflow like what you just saw, computational fluid dynamics simulation. It's relevant across very broad classes of physics and geometry in ways that are very relevant to a lot of industrial applications across a number of different industrial sectors. So what we're setting out to do here is to train AI models on GPU clusters like this, and ultimately to use that to now have deep learning models predict the physics and chemistry, sidestepping the need to be able to calculate these nonlinear partial differential equations on meshes at very high resolution, which is the computationally expensive part. And so that's what we're doing. We're allowing our customers to take the computationally expensive and slow numerical simulation out of the engineering manufacturing workflows that shape how work gets done within their 4 walls. And we're also training large models large versions of this across multiple physics, covering broad domains, many industrial applications, and these are foundation models. And so these are large pre-trained models that are usable in contexts like automotive or in aerospace, or around a number of other industrial applications as well, including semiconductors. And we're making that available as software to our customers. And so this is a composable platform that, in the first place, provides a system of record to be able to handle simulation data at scale. It has a simulation workbench that allows you to generate the training data to power these big models. It provides the tooling and the infrastructure to allow our customers to train, to fine-tune the pre-trained models that we provide, but also to be able to train private foundation models as well. And ultimately, it's a developer platform on which our customers can build arbitrarily complex workflows that are suited to and tailored to the complexity of the engineering and the manufacturing that they do. So Ferri talked about Siemens being available on the industrial cloud. Well, we let our customers stay in the tools that they know and that they trust. And Siemens is incredibly deeply trusted by industrials companies everywhere, and certainly here in Germany. And so we interoperate deeply with Siemens software that is used to train the models, to generate the training data for the models ultimately that are going to run on inference incredibly quickly in the workflows that are pushed in production. Certainly NVIDIA is at the forefront of everything that's happening around physical AI, including with Omniverse, including with Physics Nemo. And so, yes, we're building frontier models, we're building our own pre-trained models, but we also support third-party models as well, including all of the Physics Nemo models that NVIDIA provides. We can provide them to our customers via our platform. And ultimately, that allows customers like Porsche. There's a little bit of a glitch, but it allows customers like Porsche to be able to assess the efficiency, improve the efficiency of their road cars. We're working across sectors, in semiconductors, in aerospace and defense, in energy and renewables, mining and materials. These are the most important industries. They're incredibly important industries for Germany and for Europe. And so we're really delighted to be part of the software stack for the Industrial AI Cloud. It's a big moment for Germany, it's a big moment for Europe, and it's certainly a big moment for PhysicsX. Thank you.
Thank you, Giacomo. Thank you so much, and also those impressive pictures. And now a drone comes to the stage. It's, I would say, one of the rare cases that the drone doesn't fly itself, but this would have been a bit too challenging. But you see it already, and it has been mentioned in the first part as well. Quantum is with us, also a long partner, and yes, for those who might operate a drone for private purposes, yes, you know how to steer. You know how to steer a drone. You have a pad, and then you steer horizontally and vertically. And this is how it doesn't work with the quantum systems. Drones. It is much more sophisticated, and it definitely needs a lot of AI power. So I'm really looking forward, Sven Kruck, to welcome you on stage and listen to what you are going to do with the Industry AI Cloud, where you're going to use it, and what this enables this wonderful products then with. Thank you for being with us.
Thank you. Ja, wir haben heute viel gehört über die
We heard a lot about the revolution of data, of AI and how to integrate that. And now I'm going to talk about, a supplementation of data and how to actually integrate all of that into this information. In India, in Europe, in Germany, we are generating this type of data. And so the future is unmanned. This is what we are calling this. This is our motto. So you have a vector drone. So on the sea, on land, in the air, it's going to be used in order to actually fill in the AI cloud with the information that then we are going to train. On that basis, we are getting the results and we learn unmanned systems as a solution in order to increase European sovereignty and security. In addition to everything that we've heard before, robots, AI cloud, but our contribution is on land, on the sea, in the air, in order to orchestrate that, with our quantum systems, to make our own contribution. We have more than 1,000 staff globally, U.S., Mexico, anti-drug smuggling campaigns in South America, digital twins. Of course, we also are busy with that. But here we are actually dealing with urban landscapes where we are doing mapping. So this is a different kind of digital twin. So we are generating data that then we feed into this cloud. Over the past couple of weeks and months and years, indeed, talking about the war of aggression against Ukraine, how that danger evolves also and what the impact is. We have 3 staff in Ukraine, and we are, of course, defending critical infrastructure, but also at the border in order to improve strength for NATO, for Europe. And we are also doing that over or across Europe. And what are the elements that we are using? Drones, for example, unmanned aerial vehicles that are doing reconnaissance, for example, who are trying to analyze that field, around critical infrastructure, and sabotage or other such things should be prevented. We are doing this fully automated because we are not only a hardware company, but a software company as well. Together with SAP and Industrial AI Cloud, we want to become, a partner, make a contribution, learn and train and protect our critical infrastructure better. How do we integrate this element? Well, as I mentioned before, it's real-time information. We are getting information. We are producing digital twins day by day. And then our Mosaic UXS, it's the orchestration of the drones that fill our cloud with data in order to then feed it into an EU sovereign AI cloud. This is something we cannot do, ourselves having a cloud of that sort, but we can train on that basis in order for us to know how to protect our borders better tomorrow. So a whole lot of unmanned aerial vehicles, the drones, putting the information, collecting the information, putting it into the cloud, and making our contribution, being stronger in terms of European sovereignty. Real-time data, data fusion, data scalability, data security, and data sovereignty. That is where it's at, in order, at the end of the day, not only being able to work in the commercial field, but also in the field of European sovereignty, of security, and together with Deutsche Telekom as Quantum Systems, we are looking very much forward to what we are going to do in future in that field. Thank you very much.
Dankeschön. Und jetzt fliegt die Drohne wieder raus. Danke euch fürs Möglichmachen und danke, dass.
Okay, so now the drone is flying out again, so to speak. Thank you for showing it us here. And now we have another guest and a friend of ours.
friend of our house. We had him quite several times, and I think the cooperation between Perplexity and Deutsche Telekom is now really long-lasting, and it is part of a sequence of successful projects that we had, and now is the next to come, and we're really looking forward. Aravind, we already see you, what the plan is regarding Perplexity with our industrial AI cloud, because we so far had only partners from the B2B business, but now is somebody coming from the B2C business. Perplexity is well known and used all over the place. We're really happy that you could join us today via video. Please, this is your slot for the presentation. Welcome to Berlin and to our event.
Thank you. Thank you all for having me here. I'll be brief so that you don't have to tolerate me for too long on video. It's a good reminder, though. Data sovereignty doesn't mean closed borders. I'm speaking to you from San Francisco. It's 5 a.m. here, where Perplexity is being developed. But I'm able to join this event and hopefully contribute in a way that's useful to all of you. So you can see data sovereignty does not mean closed borders. It means strengthening a region. Everything that you've heard today is a very technical approach to strengthening a region or leading the European Union from Germany. There are servers, data centers, compute, and distribution. These are all the important aspects of AI, but I would argue that they're not the most important. So what is the most important part of AI? It's the same as the most important part of the European Union, the people. There is no point to all of this computing infrastructure if the AI isn't actually useful to people. So that's where Perplexity comes in. As part of joining the industry AI cloud, we're going to ensure that all the data and inference operations for European users remains in the European Union jurisdiction. In computing, we call this as inference. But what does it actually mean for people? It means that when you ask the question in Germany, the work the AI does to find and generate your answer will also be located in Germany. And why does this matter to Perplexity? The simple answer is that it matters to us because it matters to Germany. Remember, data sovereignty is not an effort to close borders, it's an effort to strengthen the region. And Perplexity has a very clear view of how people, companies, and countries get stronger. They do it by asking questions. They get stronger by learning. They get stronger through the search for wisdom. And Perplexity's mission is to support the world's curiosity. We think that the people who ask the most questions are often the most successful and do the most to change the world. Therefore, we know that the best way to strengthen the region is to provide whatever it takes to help them ask more questions. So that's why we are participating in the Industry AI Cloud. And that's also why we are very proud partners with Deutsche Telekom to provide Perplexity technology to all their users. European Union consumers ask more than 300 million questions on Perplexity every month. And that number just continues to grow at a staggering pace. So Perplexity is proud to provide the enterprise version of Perplexity to Deutsche Telekom for our internal use, as Telekom continues to lead Germany and Europe in very important initiatives like the AI Industry Cloud. Perplexity has also grown as a preferred enterprise AI provider in the EU, evidenced by 13.8x annual revenue growth in that region. 8.7x more EU companies use enterprise version of Perplexity today than they did a year ago. Think about that, 8 times growth in just over a year. So what does that mean to me? It means that Europe is already getting stronger, and everything we saw here today started with a question. Everyone here asked, how can we do more for Europe? So every vision starts that way. Every innovation starts that way. It always starts with a question. And it's questions that matter more than anything in the world. Europe's future, each European's future starts with questions. And so we are very humbled to partner with everyone here and provide some of the answers to your questions. Thank you.
So thank you, Aravind, and thank you for staying with us for the question and answer session that we do now right away. So I would ask Zhaopeng, Christian, Giacomo, Sven, please come back on stage, and if you can get a bit more light in the room, raise your hand for questions. We have microphones here, and we're happy to answer your questions. Ferri is also with us. Any questions? Yes, we have Aravind. Aravind, you are with us. I think you can't see the picture, but we have a special screen for you. So yes, any questions? Then please. Are you all tired from the morning? It was a long morning. Now is the chance. Well, then I would say thank you very much, gentlemen. You are here, so if anybody wants to do this all around.
Habt ihr alles verstanden?
Let me ask you if you've really understood everything we told you.
You will be around for the presentations and on your booth, and all those people interested for direct conversation. You're still here for a moment. Thank you very much for your presentations. Thank you.
Thank you.